Hello, and welcome to the second part of how to use a failure modes effect analysis, or FMEA, to improve your technical problem-solving strategies. In part 1, we discussed how to use a FMEA to identify potential failure modes for each component within a particular system. The second part of the series will provide an example of how to use a FMEA in conjunction with a simplified diagram or schematic to create a comprehensive FMEA that can be used as a living document. In this video, I will be developing a technical problem-solving test plan. This test plan, which is essentially an extension of the technical FMEA, will allow you as a problem solver to both improve your ability to test the system in question while also providing a method for applying both prior and future lessons learned to how you identify and correct failure modes as they relate to the system. This problem-solving strategy provides a holistic means of improving your ability to identify and solve problems while also providing a means to improve your ability to maintain the system over time. So, what is a technical test plan and how does it relate to how we solve technical problems? A technical test plan is simply a plan which compares potential and identified failure modes to an existing test procedure. This technical test plan ensures that all known failures can be adequately tested by the test. The technical test plan can also be used to incorporate problem-solving knowledge that has been gathered over time to an existing problem-solving strategy. This method allows the user to evolve his or her problem-solving strategy as experience with the system is gained. The technical test plan includes both the technical FMEA, which was created in the earlier video, the system test, and the fault isolation procedures created once the failure modes are organized. In the next video, I'm going to go in detail over how to create an effective fault isolation procedure for each of your failure modes. A technical test plan differs from a design-based test plan in that the design-based test plan focuses on ensuring that all elements of a design are tested. It also focuses on validating a particular test design as it relates to a particular system, whereas a design-based test plan focuses on potential failure modes instead of the overall system. It is important to remember that you may not capture every single potential failure mode. Rather, the goal is to identify the majority of the most likely failure modes while having a system in place to capture future failure modes and at the same time incorporating these future failure modes that are detected into the overall problem-solving strategy. Before starting, you need to identify the testing methods that are used in isolating the system faults. This will be used during this process to apply identified failure modes and validate the test being used. In step 1, the technical FMEA is organized by failure mode. Don't forget that the failure modes should be organized from most likely to least likely, as this will determine the order of fault isolation used in your fault isolation procedures that are completed later in this process. Don't worry if you don't have enough information or are not familiar enough with the failure modes to determine the order. You will be able to change the order of the failures later on when you create your fault isolation procedures. Since this is meant to be a living document, it should not be a surprise if the order of any of the failure modes requires realignment in the future as more is learned about the system. Next, in step 2, you will annotate the locations in your test where each of the failure modes can be detected. This information can come from previous testing in which a failure mode was detected earlier. The test should have a column added to the far right labeled corrective action or something similar to denote where a person performing the test should look for further information related to any failures he or she may observe. I will provide an example of this in part 3, where we step through the procedures using the sample technical test plan. In step 3, you will develop a fault isolation procedure which will be called upon in the technical test plan to narrow down and isolate each fault. These fault isolation procedures will also have enough detail to allow newer problem solvers to better understand both the failure mode and how the failure mode affects the system. Once again, don't worry about if you do not have enough information to create fault isolation procedures for every single potential failure mode that you have identified. You will be able to apply future lessons learned to any identified faults at a future point as you learn more about the system. In this example, I have created a failure mode worksheet. Essentially, the failure mode worksheet is a technical failure mode effects analysis that has been categorized based upon failure mode. As you can notice here in the far left-hand column, I have sorted all of the observed failures based from most likely to least likely. As you can see in this first example, I have 5 potential components that can cause the same failure mode. I have categorized these in most likely to least likely. Now, as you perform this test, you may realize that the most likely to least likely may change. All you would simply do is you would change the fault isolation procedure to reflect this information. You can also change this worksheet if you'd like. It just depends on how you like to do it. I like to do both so I can stay organized and have a better idea of how I have structured my personal problem solving. But I've also seen where a person may only use this as a worksheet. As you apply these to your test, you can either highlight them or mark them to show that you have applied them. You can also highlight these to show when you have created a fault isolation procedure for each of these. In this second page, I've added additional failure modes that we could apply to our test plan. Here is a very basic waveguide pressurization test that I've created that we can show how to apply the observed faults from your worksheet into your test. On the right-hand column, I've added a column that says abnormal result or corrective action. It depends on what you want to call it. So in this column, you would identify where in the test you would be able to observe the failure mode. And then you basically would just write what the observed fault would be. Like for instance here I have, if low pressure light remains illuminated after 20 seconds, then perform constant low pressure light indication fault isolation procedure. This both tells me the failure mode, the low pressure light remains illuminated after 20 seconds, then it also tells me which fault isolation procedure to use. The fault isolation procedures can either be added to the end of the test, or you can make a separate fault isolation manual. Once again, I've seen both, and it just depends on the individual. My recommendation is for more complex faults that have a lot of faults, I would create my own fault isolation guide. If you're only dealing with a handful of different abnormal faults or faults, then I would stick with just adding them to your test. Once again, it just depends on how organized you want this to be. These fault isolation procedures correlate with each of the observed faults that you have in your worksheet. I will provide extended detail in the next video on how to create a comprehensive and effective fault isolation procedure for each of your identified failure modes. Thank you very much for watching this video on part 2 of how to apply a technical FMEA to a problem-solving strategy. In part 3, I will be going over a fault isolation procedure in more detail so that you will be able to have a comprehensive problem-solving strategy that will allow you to create a technical FMEA which will provide the structure for identifying all of the faults in the system that are both known and unknown and will be detected in the future. It'll also allow you to create a technical test plan which includes the Technical FMEA worksheet, a methodology for applying the observed faults into an existing test. A Technical FMEA allows the problem solver to identify potential and future faults, create a worksheet which allows the problem solver to identify how each of these potential failure modes can be tested within this system, and will also allow the problem solver to capture and create fault isolation procedures that can be used at a future date to better improve his or her problem solving. Thank you very much once again for taking the time to watch this video.